In the previous lesson, we talked about the symbolic representation between two quantities, and that's when we came up with an equation to show that relationship between the two quantities. Now we're going to go over the visual or the graphical representation between the two quantities. And I'm going to show you how to do this by hand, which should be a review, but then I'm going to show you how to additionally draw the scatter plot on the calculator. So in the first example, it says, in Europe and Asia, m-commerce is popular. M-commerce users have a special mobile phone that works with electronic wallets as well and provides phone and internet services. Users can do everything from paying for parking, to buy a TV set or a sofa, from a machine to banking to checking sports scores on the internet. For the years 2000 through 2004, there is a relationship between the year and the number of m-commerce users. Construct a scatter plot and let X be the year and Y be the number of m-commerce users in millions. So this column here is in millions. And then this is the year. All right, so to graph this by hand, first we want to look at our minimum and maximum values for X so that we can figure out how to scale this. My minimum value is 2000 and my maximum value is 2004. So a good way to scale this is to start at 2000 and go up by each year to 2004. Now, because we're not starting at 0, we need to put in that graphical compression symbol to show that we're compressing the graph that's between 0 and 2000. So we're going to start here at 2000, then we're going to go to 2001, 2002, 2003, up to 2004. It's very important that each of those tick marks represents the same value. So each of these represents 1 year. Now, for the y-axis, we have a minimum value of 0.5 and a maximum value of 47. So I'm going to scale this from 0 to 50, and I'm going to go by tens. Now, you can choose how you want to scale it, but you want to try to stick close to your minimum and maximum value so everything doesn't get all squished in on the graph. It needs to be spread out somewhat reasonably. So I'm going to have 10, 20, 30, 40, 50, and then this is users in millions. All right, now once we have everything scaled, we're going to start plotting these XY points. Now, I didn't have to draw that compression symbol on the y-axis because I started at 0 on the y-axis. So let's see. For the first point, I have the year 2000 and I have 0.5. So at 2000, I'm going to be really, really low down here. At 2002, we have the 0.20 on the y-axis. So I come over to 2002. If you notice, if you forget how to do this, I look to see where the X and the Y pair up, where they intersect, if I imagine where those lines cross. Now for 2003, we have 33. So a little bit past 30, somewhere in here. And then at 2004, we have 47, so a little bit before 50. So here is our scatter plot. Now, this is how you want to do it by hand. Now, if you're doing it by hand, you want to make sure that your axes are labeled, that each tick mark is worth the same amount, and you also want to make sure that you have all your points spread out so that they're not all bunched in together so it's hard to read, but you also want to make it so that you have all the points included on your graph. So let me go through and show you now how you can graph this on your calculator. Okay, so to make a scatter plot on your calculator, you want to first enter all of your X and Y values. So you do that in the Edit Lists under the Stat button. So I'm going to hit the Stat button and I'm going to go to Edit. You're going to clear, if you have something already in there, make sure you're clear your L1 and your L2. In your L1, you put all your X values. So I'm going to go through and put 2000, 2002, 2003, and then 2004. And I'm going to put in all my Y values that represent the number of users in millions. So that'll be 0.5, 20, 33, and 47. Okay, now that you have everything in there, so your X's should be in L1, your Y should be in L2, make sure that they line up. These are ordered pairs, so 2000 needs to be matched with 0.5. You can't have them out of order. Okay, the next thing you want to do is you want to click on your Y equals button, and if you have something in there, you want to make sure it's cleared out. The reason for this is that you don't want to, when you graph your scatter plot, have other graphs overlapping and cause confusion and make it hard to read and all cluttered. So make sure all of your Y's are cleared out by going to Y equals and then hitting clear on everything. Okay, once you make sure that none of your equations are going to overlap and interfere with your scatter plot, then what you're going to do is you're going to access the stat plot that's above the Y equals. So I'm going to hit second Y equals to access that stat plot. I want to make sure that my plots are off except for one. Again, that's to make sure that we don't have any overlapping graphs. We just want to graph one scatter plot at a time. So I'm going to hit enter on 1, and I want to make sure that this is turned on. I'm going to hit enter on and make sure that it's blinking now on. If it's on off, make sure you toggle over to the on option and click enter on the on. Now, underneath where it says type, you want to make sure that you click on the first option, which shows a scatter plot. And then you want to tell the calculator where you put your X's and Y's. I put my X's in list 1 and my Y's in list 2. If you forget where to get your L1 and your L2 from, that is above your 1 and your 2 button, so you'd have to hit second first. If you have something already in your L1 and L2 button and you use different lists, just make sure that you put the appropriate list in there, what you put in for your X's and your Y's. Okay, once you have this set up, then what you want to do is to graph it, you want to hit the zoom button. And we're going to tell the calculator to automatically adjust the window so that we can see all the values. So instead of us scaling it by hand and manually, we can tell the calculator to do that for us. So when I hit zoom, I'm going to scroll down and hit option number 9 that says zoom stat. And then I'm going to hit enter, and then it's going to set up the graph for me. Now I have all these points listed. This looks very similar to what we did by hand. A couple things you can do. If you want to see how this was scaled, if you hit the window button, it will show you how it was scaled. So your X minimum is starting at 1999.6 and it stops at 2004.4, and that was done on a scale of 1. So when I go back to the graph, I can see that it starts here and it goes up by 1 each time. Now for the Y, it starts at negative 7.405 and it stops at 54.905, and again it goes on a scale of 1. Now when I go back to the graph, you can see from 0 to 50, that's a lot of tick marks, which is why it's really hard to read because it's really cluttered and close together. If you want to adjust the scale so you can see that better, you can do that. When you go back to window, if I want to make my scale bigger so I don't have so many lines, and I want to make it the way that we did it by hand, I can tell it to scale it on by tens. So each tick mark will be worth 10 instead. And then when I go and hit the graph button again, you can see now it goes up by tens rather than by 1. So this is 10, 20, 30, 40, 50. One more thing that's kind of interesting to show you, if you want to see what these values are and double check the points, if you hit the trace button, you'll see up at the top it will say what you're tracing. So you're tracing your scatter plot for L1 and L2. And if you use your arrow buttons, it will hop from point to point and cycle through. And then at the bottom, it will tell you the value of where your cursor is blinking. So right now, it's blinking on this point, and it's telling me it's sitting at the point 2003, and for X and Y is 33. For the second example, it says Amelia plays basketball for her high school. She wants to improve to play at the college level. She notices that the number of points she scores in a game goes up in response to the number of hours she practices her jump shot that week. She records the following data. So she has X is the number of hours, and then Y is the number of points she scored in a game. So when we make this scatter plot by hand, we're going to put the number of hours practiced on our horizontal or our x-axis, and we're going to put points scored on the y-axis. Now to scale it, it looks like my minimum value is 5 and our maximum value is 12 for the x-axis. So I'm just going to go and scale this from 0 to 15, and I'll scale it by ones. Now, for the points scored, my lowest value looks like 15, and my highest value is 36. So I'm going to graph this from 0 to 40, and I'll go by fives. Okay, so now we can go ahead and plot our values. So I have an ordered pair of 5 for my X and 15 for my Y. So that'll be right here. And I'm just going to go through and make sure I graph all my points. So 7 to 22, 9 and 28, 10 and 31, 11 and 33, and then 12 and 36. So here's my scatter plot. Now let's do this on the calculator. All right, so we need to put our X and Y values in under the list. So I'm going to hit the Stat button, and I'm going to go to Edit for my lists, and I'm going to make sure that in L1 I put my X's, in L2 I put my Y's. So I'm going to put in 5, 7, 9, 10, 11, and 12. And then for my Y's, I'm going to put in 15, 22, 28, 31, 33, and then 36. You might want to do a quick spot check to make sure, since these are ordered pairs, that 7 is matched with 22 or 10 is matched with 31. You want to just make sure that the order is correct so that your X's and Y's are matched up appropriately. All right, so I know that I don't have anything in my Y equals because I cleared it out in the first example. So now I'm going to go to Stat Plot, and I'm going to go in and I'm going to make sure everything is set up. It's on scatter plot, and I have my X's in list 1, my Y's in list 2. And then I didn't mention this before, but where it says mark and color, you can actually change those. Those are optional. If you have that option, you can go through and say, okay, well, I want to mark my points with maybe a plus instead of a square. Or maybe I want to use a different color. So you may have those options if you want to change it. So let's try red this time. Okay, now to graph, I'm going to hit zoom. And then I'm going to choose the option that says zoom stack so that it will automatically adjust the window for me. And now I have my points plotted here on the graph. And then again, just a quick reminder, I can toggle from point to point to see what they are by hitting the trace button, and it will tell you up here what you're tracing. And then I can use my arrow buttons to hop from point to point, and it will tell me where that cursor is sitting. It will tell me at the bottom what my X and my Y value is. And this last topic for this lesson, I'm going to talk about something called linear correlation. Now, we use the symbol or the letter R, and that gives us some value to represent linear correlation. Now, that value of R is always going to fall between or equal to -1 or +1. Now, there is a way to calculate it by hand, and I'm going to show you how to calculate this on the calculator, but we're going to wait to do that in the next lesson. For this lesson, I just want you to be able to look at the value of R and understand what it means. So, if I were to look at a graph of a scatter plot and I notice that all the dots or all the points are lined up so that if I draw a line, they lie exactly on the line. Every single point will lie on that line. This is called a perfect linear correlation. Now, the sign of the value of R, whether it's positive or not negative, depends on the way that the line is tilted or the slope of the line. So if the line is tilted up so that when you look at the graph and you read it left to right, it goes up, then that's going to be a positive correlation. If you look at the graph and you imagine that the line, when you trace it, goes down left to right, that's going to be a negative correlation. And all that tells us when it's a positive correlation, both of the quantities are changing in the same direction together. So as one increases, the other one increases. And as one decreases, the other one decreases. A negative correlation just means that the quantities are going to change in the opposite direction. So if one increases, the other one's going to decrease. So when you see that all the points are perfectly lined up so they fall all exactly on one line, that's a positive correlation, and that means the value of R is going to be +1. So it's going to be exactly 1 if the points can lie exactly on a line, and then the positive or the negative value will just tell you which way it's tilted. So if it was a positive negative correlation, then R would be -1. Now, if the points are close together and they look like they're really close to a line, but they're not exactly on a line, then you can say that there's a strong or a high positive correlation. And we're saying that it's positive because I imagine that that line that comes up through those points is going up left to right. Now, when you have a strong or high positive correlation, typically your R value is going to be like in the high 80s or 90s. So let's just say about 0.90, just a rough guess. When you have a low positive correlation, that means you can still imagine a line that comes up through the points. However, it's not as close to the points as the previous examples. They're a little bit more spread out. And when you have a lower correlation, it's usually like 0.3 or 0.4. The further away out from the line those points get, the closer it is going to be to 0. The closer the points get to the line, the closer it's going to be to the value of 1. And then the positive and the negative sign just tells you which way the line is tilted. If you have no correlation, that means you can't imagine any kind of line passing or coming close to all those points. When there's no correlation, your value of R is going to be 0. This example here is a low correlation, so the points are pretty spread out, but I can still imagine a line that comes through those points. And because the line is going down left to right, it's going to be a negative correlation. This one has a high negative correlation. The points are pretty close to the line, but it's tilted down. So going left to right, it's going down. So that's a negative correlation, but it's a strong or a high correlation. And then here's our example of a perfect negative correlation. I can see that if I draw a line, it passes through all of those points. So when you have a perfect negative correlation, your value of R is going to be -1. It's 1 because it's a perfect correlation, and then the negative just tells me which way the line is tilted. So for correlation, R is going to be always between +1 and -1. The closer to 1, the better the line fits the data. And then the positive and negative just indicates which way the line is tilted. So this is an increasing line, left to right, and negative means it's a decreasing line, left to right. Now, if we take the value of R and we square it, that value is called the coefficient of determination. That value basically tells us that it's a ratio of the explained variation over the total variation. The closer the R squared value is to 1, the better the line fits the data. So the percentage that cannot be explained is going to be 1 minus R squared. This is the ratio or the percentage. When you do 1 minus R squared, it's a decimal, but you can change it to a percent. This is going to be the variation that is due to random chance or possible error. So, for example, if R squared came out to, say, be 0.8, then I can say that 80% of the variation can be explained based on the way that the x and the y are changing. So that's a good variation. It's what we expect to happen based on what we're plugging in for x and y. Now, the 1 minus R squared is the complement. So if R squared is 0.8, then what we can't explain that's due to random chance or error, that would be 0.2 or 20%. So the closer you are to 1, if you're looking at it as a decimal, or the closer you are to 100%, is the better fit of the line for the R squared.